All right, so in 4.6, we're going to talk about complex numbers. So far in math, you've mostly been working with real numbers. And let's draw a map of all the numbers that you've learned so far. So the first numbers that you ever learn are your natural numbers. And these are your counting numbers 1, 2, 3, etc. Those are all natural numbers. The next kind of number that you learn is 0, right? You add that to your list of numbers, and these are called whole numbers. So your whole numbers are all the natural numbers and 0. Now, the next kind of number that you would learn are called integers. Now, integers will include all of your whole numbers, right? They'll include 0, 1, 2, 3, etc. They also include negative whole numbers. So -1, -2, -3. Okay, so integers are all your whole numbers plus negatives. Then you're going to learn about rational numbers. Now, rational numbers include all of your integers, and they also include fractions. So a rational number is defined as a number you can write in a fraction. So 1/2, 3/4, those are rational numbers. You could also have, your whole numbers in 0, right? Because you could write 3/1, that's a fraction, or 0/5, that's a fraction, and those are both equal to 3 and 0. So those are all different kinds of rational numbers. After you learn about rational, you'll learn about irrational numbers. And these are those numbers that are never-ending decimals. So, for example, pi, right? Pi is 3.14 something, 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 and it goes on for forever. It never ends. And same with the square root of 2. The square root of 2 is a never-ending decimal. So those are called irrational numbers. Now together, your rational and irrational numbers make up real numbers. Right? Your real numbers include everything, every kind of rational number, every kind of irrational number. Those are all real numbers. Now, what happened, for a while, these were all the numbers that we had. Okay, and mathematicians were doing their math, and they were proving theorems and finding new theories and all this stuff. And what kept happening was they kept running into problems because they needed to take the square roots of negative numbers. Right? So they need to find maybe the square root of -12, but they can't take the square root of a negative number, right? Because the square root means we're looking for something times itself, and we can't get the same number times itself to get a negative number. So they were always running into these problems, and they would have to start over and try and find a new way to solve these problems. Until eventually, someone said, you know what? I'm going to make a new number. Okay, and this new number they called I, and I is a number such that I times I is equal to -1. Now, if I times I is equal to -1, that means that the square root of -1 is equal to I. So they made this new number that ended up allowing them to find square roots of negative numbers, and they could keep working on their theorems and different problems instead of having to try and find new ways to do things. So I is what we call an imaginary number. Now, this isn't a very good name because it implies that I is not a real number. And while it's not included in these real numbers, it is a number that exists, right? Before we had numbers like 1, 2, 3, 4, 5, all those numbers, they didn't exist before humans started counting and using numbers. And in the same way, I is a number just like 1, 2, 3, 4, 5, 1/2, 3/2, pi. They're all numbers. So I is equal to the square root of -1. And we know that I times I is equal to -1, right? I times I would be I squared. Okay, so that would be an imaginary number. Now, complex numbers include all the real numbers and all imaginary numbers, and they take the form a plus bi. Now, all of our real numbers are going to be numbers where a is a number and your b would be 0, right? So technically, 3 plus 0i is just 3. So it includes all your real numbers, but it also includes different complex and imaginary numbers, because you could have something like 2 plus 4i, and that would be a complex number. Okay, so complex numbers are in the form a plus bi, where a and b, let's see, I don't have enough room for that. A and b are real numbers. Okay, so a and b come from our real numbers, and then I is our imaginary part. Now, let's look at how this would look on a number line. So when you first start making number lines, you make them with your real numbers, right? 0, 1, 2, 3. This would be a number line. -3 with all your real numbers. Okay, so you'd also have like a half, or you could have pi on there. All of your real numbers are included in this number line. But now, where are we going to put our new number, I? Well, instead of having just a number line, now we're going to actually create a number plane. So remember, a plane is a whole flat area, so kind of like a whole piece of paper. This whole thing is a number plane now. And I is going to go right up here. I, 2i, 3i, and same, we have negatives. -2i. Okay, so this is our number plane, and it includes all of our complex numbers. So for example, right here, that's the number 2 plus I, right? 2 plus I. And this is kind of hard to think about, but it's just like if you would put a number on your number line. Let's see, so that would be 2.5, right? 2.5. This is the same, it's just a number. It's 2 plus I. That's a complex number. So this is the complex number plane. Okay, and so the reason we have these are so that we can take the square roots of negative numbers.